So this is an introduction into Newton Raphson. So Newton Raphson will approximate this root here. Okay, that's what we're eventually going to get to. Okay, and it does that. I'll show you kind of in more detail in a minute by using a start value, drawing a tangent at a point, and then finding where that tangent crosses the x-axis, and then repeating that until we get close to the root. Okay, so first of all, we're kind of going to rearrange something to get to the Newton Raphson kind of formula. So if I wanted to find the gradient of this tangent, okay, so that would be f prime of x0. Pen's not working, good start. Okay, so we're trying to find the gradient. So remember my differential, so my prime is the gradient. So I use the change in y, which is f of x0, divided by the change in x. So it's x0 take away x1. Okay, so I can divide by f prime and multiply by x0 take x1. So they kind of swap places. So I end up with x0 take x1 equals f of x0 over f prime of x0. Okay, so these two have just swapped places. Okay, and then I'm going to take away x0 from both sides. So it's negative x1 equals negative x0 plus f of x0 over f prime of x0. Okay, and then obviously multiply everything by -1, so we get that x1 equals x0 take away f of x0 divided by f prime of x0. Okay, so that means I can find this value here where it crosses the x-axis by doing this calculation. Okay, so in general, if we want to generalize this, we've got x of n plus 1 equals x of n take away f of xn divided by f prime of xn. Now this is Newton Raphson. Okay, so this is a bigger version of this graph, just so you can see what Newton Raphson actually does. Okay, so this point x0 down here, okay, we find our y value, which is here, and we draw a tangent at that point. Okay, so we use x0 and then we sub it in, and it helps us find this value here, which is x1. And then we do the same, if we do Newton Raphson again, the same thing happens again. So we draw a tangent here. So this point is x2, and then the same again. Okay, until we can approximate this solution to kind of the degree of accuracy that we're asked for, or a suitable degree of accuracy. So that's the process that Newton Raphson uses. Okay, it's been derived from the gradient. So we can find our next value, okay, by doing the previous value, take away, and then subbing the previous value into our function, and then subbing the previous value into the differential of our function.